Functions and graphs is where we're going to live today. Yay. So first thing that we're going to talk about is a relation. And a relation is just a set of pairs of input and output values. Do you know what we call those typically? Inputs and outputs? Yeah, input is the X. What are you putting into it? That's your X. Your output is what you're getting out of it. That's your Y. Okay, so input X, output Y. And there's 4 ways that we're going to represent a relation. Okay, it's a relationship between these two things. Can't see you right there. There we go. So you can show a relation as an ordered pair, which is what I gave you there, all these different ordered pairs. You can show it as a mapping diagram. I know you did this in Algebra 1 if you took Algebra 1 here. Remember the mapping diagram? It's kind of 2 boxes, 2 columns. You have this over here and this over here. Do you remember the rules with mapping diagram? What goes in the left side? Those are your X's. And what do you do with your X's? You put them in order and no duplicates, no repeats, right? So if these are all our X's right now, negative 3, 3, 4, 4, negative 3, 3, 4, 4. That sounded like too many. You would go negative 3, 3, and 4. Okay, I know there's 2 4s. We only write 1 for a mapping diagram. Our Y values, we do the same thing. So we have negative 1, 2 of those, but we just write it once, a 3, and a 4. Okay, now the way we do a mapping diagram is we draw arrows. So we're going to connect all of our points. Negative 3, 4 would be negative 3 connected to 4 with an arrow. 3, negative 1, you take the 3 and you go to the negative 1. 4, negative 1, you take the 4 and you go to your negative 1. And then the last one is 4, 3. Okay. Now, the way we check, is that a function, is we look at our X's. This is the only place that matters. Okay. The Y's don't matter. It doesn't matter how many Y's, how many arrows are pointing to our Y's. What matters is, are there 2 arrows coming off of an X? And if you look here, there are 2 arrows coming off of that 4. So we would say this is not a function. Okay, if there's 2 arrows coming off of an X, you cannot have duplicate X values, is another way that you could say that. No duplicate X values. Okay. So that's one way we can represent it. We can also represent it with a table, which is basically what our ordered pairs look like, but we call this a T-chart a lot. We have our X and our Y, and then we have all these points. So we have negative 3, 4. We have 3, negative 1. We have 4, negative 1. And we have 4, 3. So those ones, you just list your points. We want our X's across from our Y's exactly how they came over here. Okay, so it's just those same points, but in a chart setup, in a table. And then the last one is we can graph those points. And we're just going to freehand graph this right now as best we can. When you need to graph, though, put it on a grid, put it on a coordinate plane in the homework. It's just much more accurate. Okay, so we have negative 3, 4. All right, that's going to be over here. We have 3, negative 1. 1, 2, 3, negative 1. We have 4, negative 1. And we have 4, 3. I'm going to talk about this later, but do you guys remember the vertical line test? No? Okay, then let's just talk about it later. Never mind. Do you?
Yeah.
What did it say?
If 2 points are on the same.
Yes, yes.
Exactly.
Then
if
what?
The same vertical line. Then like.
Is it a function?
Not
a function. Right. Yep. We'll get there. We're going to talk about it in just a minute. Okay. Domain and range. Which one's your domain? X or Y? X is your domain. Your input is your domain, your output is your range. So when we talk about the domain of a function, we're saying what are all the x values in that function. When we talk about the range of a function, we're saying what are all the y values of that function, okay? The x is the independent, the y is the dependent. Do you know why? Does that make sense to you? Why would x be independent?
It's the base number, it doesn't change.
You can put whatever you want in, right? It's independent. I can put in a 7, I can put in a 3, I can put in a -1. The y, what comes out of it, dependent on what you put in for your x, okay? So independent versus dependent, that's how I always think of it. Independent, because x can be whatever it wants. What you get out of it depends on what you put into it, okay? Okay, so if you look at this example above, let me erase all this so you can see my numbers again. I want to know what is the domain and range. Now, domain and range, like I said up here, no, well, let's just write it. Oop. We can have no repeats, and we want to put them in order. Okay, those two things, no repeats, put them in order. So my domain, we already did this. It's our mapping diagram numbers, right? My domain would be -3, 3, and 4. And you just put them in the little squiggly brackets. That's how you list it. The range then, same thing, -1, 3, and 4, right? So here was my domain. Here is my range. Oh, yikes, sorry. So a mapping diagram does domain and range for you if you set it up properly. Questions on any of that? This should all be review. You've done this before, probably like day 1 of Algebra 1. Okay, so a function. A function is a relation where every element of the domain, so your x, every x corresponds with exactly one y. So your x corresponds with exactly one y. In other words, you can have no repeating x values in order for it to be a function. So if you look at this first one here, is this mapping diagram a function?
Yes.
Yeah, because you don't have any repeating x values. There's not 2 arrows coming off of it, right? So this would be yes, that is a function. There are no repeating x values. Okay, that's a function. Look at letter B there. And now here's the thing, guys. You can set it up as a mapping diagram if you want, but you don't have to, right? You can see if there are repeating x values just by looking at it. All we're looking at here is this, that. Okay, the y's don't matter. The y's do not impact whether it is a function or not a function. Is this a function?
No.
Why not?
Because then it would be 4 twice.
You have 2, let's write that a different way. You have 2 4s, okay? If you have 2 4s in your x's, it is not a function. Okay? The other thing that Chris just so lovely, wonderfully explained to us is the vertical line test. That will tell you if something's a function or not. So if you're given a graph, you want to do the vertical line test to determine if it's a function. And the vertical line test just says, if I draw a vertical line, like you see here, and here, and here, if I pass through more than 1 point, it is not a function. If I pass through 1 point or less, it is a function. And that's everywhere on the graph. You should be able to go anywhere on that graph and draw a vertical line and only hit 1 point. So for this letter A, we hit 2 points. Is it a function? The answer is no. Okay. Is B a function? Yes, B is a function because it only goes through 1 point when you draw your vertical lines in. Is C a function?
No.
No. Okay. What about D?
No.
No. If I draw a vertical line, I hit in 2 places. So this is not a function. E?
Yes.
E is a function. And F?
Yes.
Yes. Okay, so if you can draw a vertical line and only go through 1 point, it is a function. Same thing here. Okay. Any questions on that? Okay, so then function notation. This tends to throw people off a little bit because they see X and they think I'm talking about X. I'm not talking about X, okay? Function notation is this. If you have Y equals 3X plus 2 and we want to write it in function notation, we write it f of X instead of Y, okay? So when you see f of X, don't think X. It's not the same as X, it's the same as Y, okay? We say it f of X, the function of X, okay? So what we're saying with that is if I plug in a value of X, what am I going to get out of it? F of X, so the function of whatever. Let me show you with an actual problem here so that hopefully it makes a little more sense. So this example number 4, it says, what is the output for the inputs -3, 0, and 1/4? Are those -3, 0, and 1/4, are those X's or Y's? Those are X's, okay? Those are our inputs. Input is X. So we have 3 X's that we need to try out here to get what they would equal, to get the value of that function, okay? So here's what we do. We say the function of -3 equals, and now we plug in a -3 for our X. So -2 times -3 plus 5. That means f of -3. So when I plug in a -3 into the function, is another way that we can say that, is 6 plus 5. Oops. So f of -3 is 11. Okay? Now understand what that's saying. This is saying if I plug a -3 into the function, I get 11, right? So this is saying y equals 11. Same thing. F of 3 and y are carrying the same weight right now. They are the same thing. Okay, so then we do it with the 0. F of 0 is -2 times 0 plus 5. So f of 0 is what? Is 5, right? -2 times 0 is 0. 0 plus 5 is 5. And then the last one, f of 1/4. So we're saying plug 1/4 in for X, which means -2 times 1/4 plus 5 is going to be, by the way, your calculator will do that for you if you're freaking out about fractions, right? Did I show you how to do that in your calculator? Math, fraction, math 1 will get you the convert it to a fraction. No? Do you remember this? Let's just, in case you forgot. Plug this into your calculator. -2 parentheses 1/4 plus 5, and you get 4.5. Now this one's simple. Like you could just leave it as 4.5 for me. That's fine. I don't care if you write your answer like that. But if you want it as a fraction, you go math, enter, number 1 is enter, enter again, and it gives you 9/2, okay? Or you could call that 4.5 if you like it as a mixed number better. I don't care which one you give me, but just so you know, math fraction, math 1 will get you a fraction to a decimal or a decimal to a fraction, okay? Any questions on that entire problem? Okay, so does this represent X? No, what does it represent? Y, right? That's like your Y value. Okay, good. Which means this is your Y value because they're equal. All right, example number 5, last thing. Oh, we have so much time, you guys. You're gonna get your homework done in class. No homework. Welcome back from the weekend. It's great. This says concert tickets are $35 plus a handling fee of $2.50. We are going to write a function rule, Okay, that means it's not y equals. Whenever it says a function rule, they want f of or any variable of. Okay, it doesn't always have to be f, by the way. Sometimes it makes more sense to be a different letter. I'll show you that right now too. But write a function rule that models the cost, which we're going to call C. Okay, so let's think about what we're dealing with. It's concert tickets that are $35 plus a handling fee of $250. So if I'm going to buy 7 tickets, I would need 7 of those $35 tickets plus a one-time fee of $250, right? If I'm going to buy 11 tickets, I would need 11 of those $35 tickets plus the $250 handling fee. So we're trying to figure out what is the total cost. Okay, so I'm going to call it C instead of F of what's my X variable going to be here?
4.
Okay, we're not to B yet. Before we set up the solve it one, just the basic one, the general function. What variable should we use? What are we working with here? Tickets. Okay, so I would say the cost of tickets, C of T, cost of the tickets. Okay, that's like F of X, but we're doing C of T to make it true to what we're working with. What's your function?
35 times T plus 2.5.
35T plus 2.5, or if you like the 250 to keep your brain in money mode, that's fine too. 2.5 is fine too. So this is your function, okay? What would it be for 4 tickets then? Yes, C of 4 equals 35 times 4 plus 250, okay? And then you plug that into your calculator. C of 4 is, what does that come out to? 142.50. Okay, questions on that? Let's review. You've seen that before, right? Hopefully. Okay, that's it for today.